Hello everyone. Today we are going to do some SOA sample problem related to module 1. So here we are going to do like around 4 to 5 problems, so you can understand how to apply the concept you learn in the module 1. Please take a moment and read the problem 1. So this problem says a survey of group viewing habits over the last year revealed the following information. So there are information. Then the question is asking, calculate the percentage of groups that watch none of the 3 sports during the last year. So we want to calculate that probability. So let's start with some notation. We can use G for gymnastic, B for baseball, S for soccer. So here you can see that the probability of watching gymnastic is 0.28. Probability of watching baseball is 0.29. Probability of watching soccer is 0.19. Then here you can see that you can see the word and, which means the intersection. So you have the probability of gymnastic and baseball is 0.14. Probability of baseball and soccer, that's 0.12. Probability of gymnastic and soccer, 0.1. And then at the intersection of all three, 0.08. So the question asks none of the 3 sports. So pretty much we want to find the probability A union, not A, G union, B union, S. But since the word none, we need the complement. Okay. Now the first thing you do, you apply the complement rule. And then if you remember the addition rule for 3 events, then now you can apply that rule and get the answer. And then finally subtract the, you add the watch all 3 sport probability. And that formula should give you the answer. So these ones, you know the values from the problem, it's given 0.28, here 0.29, this one is 0.19, this is 0.14, and this one is 0.1, and this one is 0.12, and then this one is 0.08. Once you done this calculation, you should get the answer as 52%. Let's go to the next problem. In this problem, you can see that the question is asking about the probability that a visit to PCP office result in both lab work and referral to a specialist. So if you read the question given that probabilities, you can see that visit to primary care physician office result in neither lab work nor referral to specialist 35%. So if I use a physician as P and lab work as L, I would get probability P. Let's use a different word because I don't want to use the P again. Maybe let's use R, referral to specialist. Okay. So this way you can see probability none of this. So that means basically R union L complement. That's what the word neither. Lab work, no referral. So that's given as 0.35. Okay. So right here, you can find that probability R union L is going to be 1 minus probability using complement rule, which is going to be 0.65. And then the question says 30% are referred to specialist, 40% require lab work. So probability of referral is 30%. Probability of lab work is 40%. And the question asks a result in both lab work and referral. So we want to find the probability R and L. Of course, you can say that if you use the addition rule, this should be this is a easy problem. So if I apply the addition rule to this one, R union L, you would get probability R plus probability L minus probability R intersection L. And now this side, you know, it's 0.65. This is 0.3. This is 0.4. And this is what you want to find. So the if you solve this, the answer should be 0.05. Let's go to third problem. Treat the problem. So the question given us two different probabilities, and we want to find probability of A. Again, we apply the addition rule. You can see that we are applying addition rule several times for problem 1, 2, and now the third one. So if I apply probability A union B, that's going to be probability A plus probability B minus probability A and B. Okay. Then if I apply the same rule to the A union B complement, that's going to be probability A plus probability B complement minus probability A and B complement. Now I can add these two equations. And if I do that, I would get probability A union B plus probability A union B complement in the left hand side. And then the right hand side, I guess two probability of A. And when you add these two, remember that probability of B plus probability B complement, that should give us 1. Then I have these two other probabilities. Okay, so this value is known, that's given as 0.7, and this value is known, that's given as 0.9. So, and this is what we are really looking. Yes, we want to calculate that value. So then somehow we need to simplify this probability A and B and probability A and B complement. So let's see what is that. So if you add probability A and B plus probability A and B complement, this is same as probability. Let's draw a Venn diagram and see what is it. So I have A here, B here. So A and B is this part. Then A and B complement, that's going to be this part. So you can see that that's going to give us A. So this is going to be A. So this, when you add these two, that's going to be probability of A. So I can rewrite this equation as 0.7 plus 0.9, that's left-hand side. And the right-hand side, I have 2 probability A plus 1 minus probability of A. And this gives us, you can simplify this and find the probability of A. You should get 0.6 as your answer. Let's go to the next problem. In this particular one, the question asks us to find the number of blue balls in a second urn, which is unknown at the time. So you can, if you read the question, it says there are 2 urns. The one contain 10 balls with 4 red and 6 blue. And the second one contain 16 with unknown 16 red balls and X number of blue balls. So single ball is drawn from each urn. The probability that both balls are the same color is 0.44. So we want to find the X or number of blue ball in the second urn. I can easily draw a tree diagram. So let's say the first row from the urn 1. So then the probability of getting red ball is 4 out of 10. And probability of getting blue ball is 6 out of 10. Then the second urn, probability of getting red ball is 16 over 16 plus X, because total is 16 plus X. In here, total is 10. And then the blue ball is X over 16 plus X. So the question asks, give us one probability, the probability that both are same color. So let's go to the next one. Here, if you get the red, that's going to be 16 out of 16 plus X. Then the blue ball, that's going to be X over 16 plus X. So the same color mean red, red or blue, blue. So if I get this probability, that's going to be 4 over 10 times 16 over 16 plus X. Blue, blue, that is going to be 6 over 10 times X over 16 plus X. Now, when you add these two numbers, that is equal to 0.04. 0.44. So your task is solve that equation and get the X value. So basically you get the equation 4 out of 10, 16 over 16 plus X, plus 6 over 10, X over 16 plus X equal to 0.44. Solve for X and you should get the answer as 4. I leave you the solving part for yourself. It is a simple linear equation. Here you can see the last question we are going to do. The question says auto insurance company has 10,000 policies. Then they give us different classification, young or old, male or female, or married or single. Then they give us some information. And then at the end, the question asks, calculate the number of, not the probability, number of companies policyholder who are young, female, and single. So we can start, we know that total is 10,000. Okay, so let's start from the information given. 3,000 are young. So I can divide 10,000 to young and old. So here I have 3,000 young and then 7,000 old. Then I have the male and female, the next category. Since we are focusing on young, I'm going to focus on the young branch. Okay, so then I can divide it to the male and female. So total 1,320 is going to be male. Then how many females? 3,000 minus that much. 13, that many, 1320, that's female. Then the last category is married or single. Now I can divide this as married and single. So this is young male married, young male single. And also I have female, young female who are married and single. So the question says, instead of giving us how many young males are married or single, the question says 1,400 young married persons. So, and then it also says 600 of policyholders are young married males. So 600 here young married males. And then if I want to know this number, the young married females, that is 1,400. So 600 plus X is 1,400. That give me X, which is 1400 minus 600, which is 800. Okay. So in that case, then how many young female singles? That's going to be 13,000. In 20 minus 800. So that would be the answer. The final answer should be 880. Okay, that's all for sample problems for module 1. Let's meet again in module 2.